Alright, students, today we are going to learn prove perpendicular line theorems. I'm going to use a format called Pictionary conditionals. What it does is it takes an F1 statement and it changes it into two separate pictures. Before I actually get started, I want to write down a couple of review items. First thing I want to review is, and I always write my review items over here, it's stuff I already know. The first one I want to write down is transversal. What is a transversal? Who knows? Go ahead. A line that, there you go, a line that intersects. It doesn't have to be parallel lines. It is a line that intersects two or more lines. And those lines don't have to be parallel. They could be, but they don't have to be. Speaking of parallel, can somebody share with me what is the symbol for parallel? Yes. Okay, so I see people holding up their arms that look like two uprights. Yes. Parallel . Okay, now let's review what is the symbol for perpendicular. Yep, I see it. I see a bunch of T's and now you're turning them over. Okay, so upside down T's. Perfect. Okay, so that's perpendicular. Alright, let's go ahead and get started on our first theorem. The first theorem says if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. And I'm just, instead of writing the word perpendicular, I'm going to put the symbol perpendicular. So our Pictionary conditional will start off with line 1 intersecting line 2. When these two lines intersect, it's going to form four angles, 1, 2, 3, and 4. And so what we want to show is that these angles are congruent because it says that it's a linear pair of congruent angles. So 1 has to be congruent to 2, 2 has to be congruent to 3, 3 has to be congruent to 4, and 4 has to be congruent to 1. When that happens, then we know that line 1 and line 2 are perpendicular. So if this happens, then we know this is true. Now, we're going to write a traditional or more traditional conditional statement using these examples. So, if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, and angle 3 is congruent to angle 4, and they're all congruent. See how I wrote them in a line? So everything's congruent to each other. And the angles are adjacent. Well, they form a linear pair. I'll change that to, and the angles form a linear pair. Then line 1 is perpendicular to line 2. The next one. It says if two lines are perpendicular, so we're going to start our Pictionary with that one. Let's draw two perpendicular lines. This time it kind of starts backwards. So I have these two lines and they are perpendicular. Here's line 1, here's line 2. That's how I show that two lines are perpendicular with the little right angle symbol. So if I have that, then what? Okay. Then they intersect to form four right angles. Now folks, this is a theorem. If two lines are perpendicular, then they intersect to form four right angles. That sounds very familiar to something else that you've been dealing with so far. Anybody have a clue what that is? Two lines intersecting, they're perpendicular lines, they form a right angle. You used it in your proofs. I hear somebody saying it. Definition. There you go. Definition. Over here to the side, let's write that down. Definition of perpendicular lines says that if two lines intersect, if they're perpendicular, then they form a right angle. How many is that? Just one. Okay. So here, the definition will give you one right angle. But this theorem over here will give you how many? Four. That's the difference. When you're working with your proofs, when do I use the definition of perpendicular lines, or when do I use the theorem? If you just need one angle, you would use definition. If you need all four, you would use the theorem. Okay, so let's go ahead and draw this. Second part of the Pictionary conditional. This is angle 1, angle 2, angle 3, angle 4, and I'm going to make them all right angles. And I just make the right angle symbol, I just make them different sizes. It doesn't mean anything. I just make them different sizes so it's easier to see. Okay, so now we fill out our more traditional one. Here, if line 1 is perpendicular to line 2, then we know that angle 1, angle 2, angle 3, and angle 4 are right angles. Now, folks, question. Does this theorem say if line 1 is perpendicular to line 2, then the measure of angle 1 is 90 degrees, the measure of angle 2 is 90 degrees, the measure of angle 3 is 90 degrees, the measure of angle 4 is 90 degrees? Careful. It doesn't say that. It calls them right angles, and you must use the definition of right angle to get them to change into 90 degrees. See the difference? Okay. All right, so now we have the next one. Theorem. If two sides of adjacent acute angles are perpendicular, then what? Then the angles are complementary. Okay, I'm going to choose to use color on this. Okay, so my first color is blue. And I have two angles that are adjacent. What does adjacent mean? Side by side. They're actually touching. Okay, so here's one of them. Here's my blue angle. And then my next one, I'm going to choose green. here's my green angle. And really, this is really the same ray, but I'm drawing it as two separate rays, so you can think of it as two separate angles. Okay, so here, this is angle 1, and this is angle 2. So what they're trying to say here is, if the blue ray, this outside ray right here, the blue one, is perpendicular to the green ray, then angle 1 and angle 2 are complementary. Okay, so we have to write this up here. Angle 1 and angle 2 are complementary. Okay, the next one, perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. If it's perpendicular to one of the two parallel lines, then it's going to be perpendicular to the other line. Okay, so how do we draw this one? Alright, so I'm going to start here with parallel lines. So here's line 1. Here's line 2. And remember, transversal is where it intersects both of the lines. So I'm going to call this one T for transversal. So here I've got this line is parallel to this line, and it is perpendicular to one of the lines. So if I have this situation happening right there, do you see how I have it drawn where these are parallel, and I only show this one down here perpendicular? That's the F part. So they're saying when this happens, then we know, so draw the same picture almost. This is line 2. This is line 1. Parallel. Here's your transversal. So when this happens, then we know that it's going to be perpendicular to the other one. Okay, I'm going to shade this one in with yellow because this is the original, so it was originally perpendicular to this one. And when this happens, it's going to be perpendicular to the other. So our more traditional conditional statement would read, if line 1 is parallel to line 2, and the transversal is perpendicular to line 1, then the transversal is going to be perpendicular to line 2. Alright, next. Lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Alright, so here we've got two lines in the same plane. So we're going to let this rectangle here, we're going to let it represent our plane. The sheet of paper is a plane. So we're going to draw two lines. Line one. This time I'm going to draw them vertical. Doesn't matter how you draw them. Just draw two lines. This one's line two. But what you know is that two lines are perpendicular to the same line. So line 1 and line 2 are both perpendicular to line 3. So I show perpendicular with the little right angle symbols. So now for the next picture that you're going to draw, you want to draw almost the same thing, but you're going to add something to it. Line 1, line 2, line 3. They're both perpendicular, but what do you think I'm going to add to this new picture? Very good. What I saw was a little arc mark like this. Okay, so I'm going to put the parallel symbol. Remember that when we are trying to indicate that two lines are parallel in a picture, we put these little symbols here. Alright, next, our more traditional conditional statement will be if line 1 is perpendicular to line 3 and line 2 is perpendicular to line 3, then line 1 is parallel to line 2. Okay, almost done. This one's not, doesn't have a name that's in bold like this one does. This one, when you're using this in your proofs, you can just call it the perpendicular transversal theorem. That one right there, because it's in bold. This one here, you can just call this one the lines perpendicular to a transversal theorem. But all the rest of them, notice how they don't have a special name? When it doesn't have a special name, that means that you have to write it all out. And these are the ones that are going to be on your yellow card. Okay, last one. The shortest distance from a point to a line is the length of the perpendicular segment. So here we're going to start off with a line in a plane. We have a line and we have a point not on the line. There's many ways for me to start at this point and to travel towards this line. I can go here and end up here. I can go way over here. I can go here. But what is the shortest? If I'm trying to measure how far away this point is from the line, and all these people are measuring for me, who is right? Well, nobody yet, because they have to measure. We all decided way back when that the shortest distance is going to be that line segment that is perpendicular to this line. So we call this length the distance between the point and the line. Okay, so if this is line 1, if this is point P, and we call this one N, then we know that the distance between P and N is going to equal that distance formula. Do you remember what that distance formula was? Okay, so y2 minus y1 squared. Do you remember? Plus 2 squared. Good. Okay. So here, F point P and line L are in a plane, and point P is not on L, line 1. Then the distance from P to N, from P to the line is Pn equals y2 minus y1 squared plus x2 minus x1 squared. Sometimes when you have problems like this, you're going to have to determine if the two lines are perpendicular. You may be given a line, and you may be given all these different lines, and sometimes it may be difficult to tell which one is perpendicular because it won't be straight up and down like this. It may be tilted and over to the side. So it may be the way to tell if something's perpendicular, you may be required to test it. Do you remember how you test to see if two lines are perpendicular? Good. It's the perpendicular line test, and you have to find their slopes. Let's write that down here so you don't have to go back to your previous notes. So remember, perpendicular line test. That's where, first of all, you have to find the slope of each line. And then step 2, you have to check to see if it passes this test. The slope of line 1 times the slope of line 2 has to equal, very good, -1. All right, folks, that's it for today.